Hello, welcome to In 5 Minutes. Now, in the reverse order, if we have given the input and output waveforms, and the question is to design the circuit for the given waveform. Now, how to go about it? For the positive half cycle, it is shown that you should get output as 2.7 volts. So, in the positive half cycle, in order to get output as 2.7 volts, if the diode is ideal, that means the voltage drop V gamma across the diode is considered as, in ideal case we are considering as 0 volts, right? If we are considering the ideal case, then the circuit, you want the output voltage, your equation VO should be equal to 2.7. that means VO minus 2.7 is equal to 0 should be the equation. So in order to have this, what we need to do, the diode should be short circuited in that case. So when you apply KVL, you will get the equation for VO. So the equation for VO, in order to satisfy this, the direction of the potential difference should be in this format, which will give you 2.7 volts. So when you apply KVL over here, the equation will be VO minus 2.7 equals to 0, which is required by us. This is how we are designing the circuit for output to be 0.7 in the positive half cycle, and the diode should be short circuited in order to have the output as 2.7 volts. So what we have found from this, the position of diode. How to draw the diagram? The position of diode should be in this way, so that it is forward biased in the positive half cycle. So this is the half part of the circuit what we have achieved for the ideal condition of the diode V gamma to be 0 volts, and this should be 2.7 volts. Now the rest of the part is just drawing the capacitor and the input. Now capacitor input voltage is 10 volts peak to peak. Now in order to cross check, what we can do is, for normal two steps, this is your VI 10 volts and minus 10 volts. Now for step 1, what we are doing is applying KVL in the input loop when the diode is forward bias. So you'll get VI positive negative, VI minus VC minus 2.7 equals to 0. So this will give you VC as 10 minus 2.7, which will give you 7.3 volts. So charge on the capacitor, we are getting it as 7.3 volts. So the charge developed on the capacitor is 7.3. So in the next half cycle, when the diode is open circuited, you should get output as minus 17.3. So let's check. In the next half cycle, we will have minus 10 minus 7.3, that is applying KVL from where to where? We are applying KVL from this point till this point. So minus 10 minus 7.3 minus VO equals to 0. So you'll get VO as minus 17.3 volts. So our both the values of output voltage are satisfied by the circuit. We are getting VO 2.7 and then we are getting VO as 17.3. This is how we have designed the circuit for the given output waveform.